Logarithms. Everyone's least favorite mathematical function, and something that I think about 50% of people sitting in the GAMSAT really neglect in their study. So today I'm going to show you everything that you need to know about logarithms, and then it'll become a strength. You know that they're going to come up, and you know that they're going to come up semi-regularly, so it's really important that you know how to manipulate equations that have logarithms in them. How I'm going to structure this video today is by firstly going through a bit of a tutorial on how to actually solve logarithms, rearrange equations with logarithms and all of that. And then we're going to go to a practice question and then apply everything that we've learned. I can almost guarantee that this video is going to be really useful for a lot of you out there. And if you do find it useful, I'd love it if you could like, comment and subscribe. Okay, so when I think about logs, there's really two things you need to understand. The first thing is being able to solve logs, and the second thing is being able to rearrange logs. So we'll start with solving logs. Now, really, what a logarithm is asking is how many times do I need to multiply the base by itself to get the number? So I've tried to color code these things so that this question makes a little bit more sense, but that is the question it's asking. I should have put a question mark at the end there. So the base is this number down here, and for the purposes of this video, we're just going to focus on logs with the base 10. You will need to do in the GAMSAT some with the log base e, which are called natural logs, but I'll do that in another video. But also essentially the concept is much the same. If you can understand this video, you will be able to get the natural logs much easier. Anyway, so we have in this video, we're focusing on logs with the base 10. And what this log is asking is how many times, which is our answer, do I need to multiply the base, which is 10, by itself to get the number, which is 100. So one more time, how many times do I need to multiply 10 by itself to get 100? Now, I think if you just keep repeating that, hopefully it'll start to make a little bit of sense. But to break this down, I wanted to just rewrite this 100 in terms of the base. So we ultimately want to know how many times we need to multiply the base by itself. So if we could represent that number in terms of how many times we need to multiply the base by itself, then that will kind of help us get the answer. So you may know that 100 is the same as 10 by 10. Okay, so if we look at that question again, it's now saying how many times do I need to multiply 10 by itself to get 10 by 10? Well, 10 by 10 is the same as 10 by 10. So if we multiply 10 by itself twice, so 1, 2, then that will give us 100. So the answer to this log is just 2, okay? We need to multiply 10 by itself twice, so 10 by 10 to get 100. Now, the cool thing about logs is really that what this part is saying, so this part here, where I've broken that number into tens, all I've done is represent that number in terms of a power of the base. So 10 by 10 is actually the same as 10 to the 2, and then you might notice that this 2 is the same as our answer. And that works for every logarithm. If you represent the number in terms of the base with a power, then you're actually you're actually solving the logarithm just like that. And it kind of makes sense if you think about it, because what a power is doing is telling you how many times you need to multiply that number by itself. So it's very much half of the logarithm if you look at the definition of the logarithm. So let's just go through a few more examples. So if we had log 10 of 1000 equals x, then we can just say, well, this question is asking how many times do I need to multiply 10 by itself to get 1000? And if you really, really wanted to, you could just break this number up in terms of tens. So if you just split this number into just multiply the base by itself however many times until you get to that number. That will give you the answer. So here we've got 3 tens, so this just equals 3. And it's as easy as that. But I actually think it's easier just to convert the number into scientific notation, because when we convert into scientific notation, that's just putting it into a power format. And that's actually telling us how many times we need to multiply by 10, which is exactly what we need for our answer. So for any logarithm, so if we had log 10 of, let's even say 1,000,000, so quite a large number, if we just convert that to scientific notation, so I'll put my decimal point here, 1, 2, 3, 4, 5, 6. If that's a little bit unfamiliar to you, I'll link my video on scientific notation and index laws, but definitely be able to do this. And this is kind of why I say it's so important. So that was 6. So we could rewrite this 1,000,000 as 10 to the 6. It's actually 1 times 10 to the 6, but we can, anything times by 1 is just itself, so we can remove that 1. So as soon as we've written it in scientific notation, our answer actually just becomes whatever this exponent is. So this logarithm equals 6. And this works for small numbers as well. So if we had log 10 of 0.0001, we just do exactly the same thing. So we go 1, 2, 3, 4. So this becomes log 10 of 10 to the power of -4 equals x. So then x just equals -4. So we just take that exponent again and make that the answer. And hopefully when you look at this rule, it makes sense why that's the case. As I've hammered it home a few times, it's just how many times do we need to multiply the base by itself to get the number? Well, when we represent it in scientific notation, we're just representing that number in terms of how many times we need to multiply it by 10. So when we have the base 10, which you almost exclusively have in the GAMSAT, that will always get you the answer. Now, I did just want to make a little note about when you have things like log 10 of 2,000. So a lot of people get a little bit stuck here. So they go, okay, James, I'll go through my process and I'll go, this is equal to 2 times 10 to the 3. So therefore my answer equals 6. Okay. Now this isn't quite right. What they've done there is they've said, okay, you said just take the exponent, but I also have this 2 here. So I've just multiplied those numbers together. So don't do this. Because really, remember, this number tells you how many times we need to multiply the base by itself. So we're now saying that 2,000, right, our number 2,000 is equal to 10 multiplied by itself 6 times, which is actually 1,000,000. So how do you solve these? Well, you actually do go through the same process. So you convert it into scientific notation. And my advice is just to take the exponent. So as I had before, log 10 of 1,000 equals 3, and log 10 of 10,000 equals 4. All right, now we can see that 2,000 is somewhere between 3 and 4. So you can calculate this, but obviously in the GAMSAT you don't have a calculator. So what you're expected to do is just estimate this number as somewhere between 3 and 4. So my advice is just to convert it to scientific notation and just kind of round it. So if your number here is closer to 1, then go to the low number. And if it's closer to, so let's say it was 8 times 10 to the 3, then I would go to 4, because really it's what number are you closer to? So is 2,000 closer to 1,000 or closer to 10,000? It's closer to 1,000, so your answer is going to be closer to 3. So I always just still do the same thing. I convert it to scientific notation, and if it's 2,000 like this one, I'll just take that 3, and in reality the number is something like 3.1. And then if it was something like 8,000 or 7,000, I would round that up to 4 or 3.5 or something like that. But the good thing is in the GAMSAT, it doesn't particularly matter what you round it to, as long as you're consistent and you know that you've estimated a number. So what they're really testing to see is, do you know how to estimate a log rather than say that this is equal to 6, which is probably quite a common mistake. So as long as you don't say 6, you'll get the right answer still. So really, it's a two-step process. You put the number inside the log into scientific notation and take the exponent. And then you just need to be a little bit careful if it's one of these kind of irregular numbers. Okay, so the second key skill that you need to be able to do is rearrange logs. So what I mean now is, before we had a number within the log and we could just directly solve that, but now we actually have a variable within the log. So in this case, it's x. So some people I find really just get it if they think about it. So this thing is saying that, remember, the log is asking how many times do we need to multiply the base by itself to get the number. So if we look at this, this is saying that we need to multiply 10 by itself 3 times to get the number. So that would mean that x equals 10 multiplied by itself 3 times. So 10 by 10 by 10, or 10 to the 3. So you'll see that really we're just reversing that. We're just pulling that answer back, same as we did before. Instead of just taking the exponent, we're now taking the answer and making that the exponent. So it's the exact same, just opposite. If you want to do it mathematically, because I think this is a really good start, but sometimes you can come unstuck with this. So how you do that mathematically, if we go with the same equation, log 10 of x equals 3, what you do is you raise both sides. So remember, we can do any mathematical operation as long as we do it the same to both sides. So if we I like to think of it as you just throw everything on each side on top of a 10. So if you just throw everything up the top of the 10, what actually happens is that these cancel out. And I said 10, I should have mentioned this. I said 10 because the base of the logarithm is 10. So this only works with log of the base 10. But if you raise both sides, that 10 actually cancels, and what you're left with is x equals 10 to the 3. So that's a mathematical way that you can do it. Either way is fine. But as long as you can solve these, whatever process you do is fine. I personally do this mathematical way, but a lot of people find it easier just to look at the log and kind of think about that question. So if we just go through one more example. So we have log 10 of x equals negative 4. So what I do is I just raise both sides. I don't know what the proper mathematical terminology for that is, but I just make both sides the exponent of the base 10. These 10s then cancel, and all I'm left with is x equals 10 to the power of negative 4. Okay, so quite easy to rearrange logs. And it doesn't matter if there's a fraction within the log. So some people get a little bit confused with if this was log 10, x over 3 or something like that equals negative 2. It's just don't freak out, just go through the process. So get rid of the log first. So 10 to the power of log 10 of x over 3 equals 10 to the power of negative 2. So it looks a little bit scary, but remember this 10 and this log 10, I forgot to do the base in there, but you know what I mean. They cancel out, so what we're left with is x over 3 equals 10 to the negative 2, and then we can just multiply 3 by each side, which will get rid of that. So in this case, x would equal 3 times 10 to the negative 2. Okay, so it's exactly the same. Just go through your process and you can really rearrange any logarithm. And just a few more things that I think you should probably know. So you can have numbers with logarithms as well. So you could have something like this, like x equals 2 plus log of this number. If it's like that, just solve it. So that does represent a number. And if we work that out, that's log 10 of 10 to the 3, which means as we're solving a log, we just take the exponent. So this just equals 2 plus 3, so that just equals 5. So if you have logs as part of an equation, you can just evaluate them first and then solve it that way, which is probably the best way. And yeah, and there's nothing really to be scared of there. So just look at them kind of like a number. And that would be the same if it was multiplied or divided or anything like that as well. And lastly, I do want to just go through a little example with the one that we did before. So I gave you the simple way, which is personally what I do. I just estimate that to be, I say that this is basically the same as 1000, which is just 10 to the 3. So I just say that x approximately equals 3 and I round it up a little bit. But if you want to be exact, there is a log rule as well. So if you have log a times b, this is the same as log a plus log b. Now I know that looks scary, but what it's saying is if you have two numbers which can multiply together inside a log, you can then separate them into two individual logs and just take those numbers. So if you wanted to do this with a little bit more precision, which I don't think you're going to need very often, but this is a good rule to know, 2000, so I'm just coming back here, is the same as 2 times 1000. So that means that by this log law, we can then say that log of 2 plus log of 1000 equals x. As we know, log of 1000 equals 3. So it's just log 2 plus 3. So this may be useful in some contexts because things like this, again, you'd need a calculator to solve that. But sometimes they do give you those numbers in the stem somewhere. So I can't remember exactly what that equals, but it'd be something quite small. So you could add those numbers together and then that would give you the exact number. I think it's something like 0.3 maybe. All right, and that's all I wanted to do on logarithms. So now I'm going to take you to a practice problem and we can put this all into action. All right, so I hope this is okay. I've got a few things on the screen and we'll see how it goes. But essentially what I've done is I've made a question which I think represents something that you might see in the GAMSAT, but basically just a question with a logarithm in it. I will also leave a link somewhere in the video to download these questions. So if you wanted to, you could pause this video, download the questions and have a go yourself. Otherwise, just sit tight and you'll get to see how I approach them. So as I've said in quite a few of my videos, I always skip over the stem and just go straight to the question because the question actually acts as kind of a filter and allows me to search for what is relevant. So question 1 is saying a seismograph records an earthquake with a seismic wave amplitude that is 200 times greater than a standard earthquake. What is the Richter magnitude of this earthquake? So just highlighting the key words. So we've got Richter magnitude. That's obviously what we need. So that's our output variable. So maybe we'll just start with that. Standard earthquake is probably going to be relevant as well. And then 200 times greater. So if we look for the words Richter magnitude, we should hopefully see that here, which is the variable m, which is given by this formula. So if I write that down, m equals log 10 of a over a0. And a is the amplitude of the seismograph, and a0 is the reference amplitude, which is just the amplitude of a standard earthquake. So hopefully you'll see, I know that I did make this question, so obviously I'm familiar with it, but hopefully you can see that that's actually quite an efficient way to approach the question rather than kind of worrying about all this stuff here, which is irrelevant. So we've got this formula, and then if we go back down to our question, it's saying that the seismograph is 200 times greater than a standard earthquake. So what we could just say is that basically this top number has to be 200 times greater than this bottom number. And whenever I see something like that, I always just think let one of them equal 1 because they're just saying that 1 has to be 200 times greater. It doesn't really matter what the numbers are as long as it's 200 times greater. So we can just say log 10 of 200 over 1, which just equals 200. Okay, so going through our process, we would have log 10 of 2 times 10 to the 2 if we convert that to scientific notation. And as I mentioned, that would mean that we would have 2 plus something. It'd be 2 point something. It'd be between 2 and 3, but closer to 2. So if we look at all our options, and I just realized I've formatted these a bit of a weird way, but this one would be option 1 here. It'd be option A, because it is greater than 2. So it's obviously not B or C. And yeah, that would be the most correct. Okay, so moving on to 2. Just get rid of that a little bit. An earthquake registers a magnitude of m equals 1.7 on the Richter scale. By what factor is the seismic wave greater than the reference amplitude? So if you think about that, we have m. So we'll go back to this formula, and we have m. So m equals 1.7, and this equals log 10 of a, which is because it says what factor is this earthquake greater than the reference. So we can just say A0, something like that. Now, in this question, we need to rearrange the log, don't we? So how we do that is we raise both sides to the power of the base. So we get 10 to the power of 1.7 equals, 10 to the log 10 a over a0. Then these cancel out, which means that a over a0 equals 10 to the 1.7. Now, this is a little bit tricky to solve, but if you just kind of think about what that means, it's somewhere between, so how I would do this is 10 to the 1 equals 10, and 10 to the 2 equals 100. So it's somewhere between 10 and 100, but it's likely closer to 100 because 1.7 is closer to 2. So that means our answer will be closer to 100. Okay, so this one will be option A, 50. Now, if we move on to question 3, it's saying that 2 earthquakes occur in different regions. Earthquake X, so I'll go down a little bit. So X equals 4 on the Richter scale, Y equals 6. And it's saying how many times more energy did earthquake Y release compared to earthquake X? So first of all, now we need some more information. So that's something so how many more times more energy? I actually don't remember writing this one, but how many more times more energy? So that's something that we need to go and understand. So if we scroll back up to the question, so each increase on the Richter scale represents approximately 31.6 times more energy released. So so each increase on the Richter scale represents approximately 31.6. So for this one, it's increased 2 on the Richter scale. So that means we get, so this is a little bit confusing. So it's 31.6 times per increase. Now we have increased plus 2. So that would mean you get, let's say you start at 1. If you increased 1 on the Richter scale, it'd be times 31.6. And if you increased another time, you'd also times that by 31.6. So it's 31.6 times 31.6, which is basically 30 times 30, which is 900. So I would say that this answer would be D, which is, answer 4. Or D. I've got both of them in there. But yeah, that's another kind of way that they often assess logarithms. So things like pH, that's a log scale, and that will say what kind of increase in acid does this correspond to when you go from a pH 3 to a pH 7 or something like that. So all of the questions that I put in are just things I had in my head for common ways that logarithms are assessed. So if you get your head around all of these, you should be in a really good spot. All right, and that's it. So if you could follow along with everything in this video, you're in a really, really good spot with logarithms. And if not, hopefully this video has shown you that they're not that hard and they're nothing to be scared of. You probably just need a little bit of practice. So what I would recommend is just getting some logarithm questions. I've got some on my website, my free ebook, if you wanted to download that. So I'll leave a link to that as well. But just find some logarithm questions, rearranging and solving, and just try solve them. Just keep forcing yourself to do them, and I promise they'll become easier and they'll become second nature, relatively quickly. So anyway, I'll leave it there for now, but I hope this video is useful. If it was, please like, comment and subscribe, and I'll see you in the next video.